This is lecture 5, example 4. Now this is a very advanced example, but once again, like I said, I want to show this to you just to give you a feel for the possibilities in assembly language programming. Now the issue with this problem is I know it's advanced, but it's actually a very good problem. It's one of the best around, simply because it does something real, does something meaningful, and it does something you can relate to. So this one is going to be a little bit longer, so I'm going to go ahead and break this up into 2 videos, and so might as well get to it. Now this is a notion of a subroutine that's going to convert the a BCD value, a 3-digit BCD value, to a binary number. Okay, so that means the BCD value is the least 3 significant nibbles in register X10. And what I want to do is convert that to binary in X20. So a couple things what I want to do on this one is draw it, make sure I understand this, and then also draw the subroutines, the flowcharts, and then on the next slide we'll actually go draw write the code for it. Okay, so this one, what it says is this is a 3-digit number in BCD format, where the lowest three nibbles, which is these 3, not drawn to scale here, represents a decimal number. So this is the hundreds place, this is the tens place, and this is the ones place. So these are each 4 bits long, which hold a nibble, which nibble is 4 bits, which is essentially a BCD value. So these values are going to be 0 through 9 guaranteed, because we said it was a BCD value. And so what I want to do is take these 3 numbers and convert it to binary. So let's draw a flowchart for this thing. We're going to actually draw 2 flowcharts for this. We'll just say, we'll call it convert, and I probably have to do some init stuff. I always do, but I'm going to keep this very high level. I'm just going to say do the hundreds, do the tens, and then I'll say add the ones, and then I think I'm done. Okay, so that's the high level flowchart. Now the low level flowchart is, I want to expand this out a bit, because essentially these 2 boxes here are kind of too high level. I want to show kind of low level details on this one. And the issue is that the flowchart for each of these boxes is going to be pretty much exactly the same. So I'm only going to do one of them. And so let's do, doesn't matter which one I do, but let's take a look at it. And so this has a specific algorithm that everyone should use when you do this thing. I know there's some other algorithms online, like I think the double dabble, no kidding, I think that's the name of it. Double dabble is such an algorithm, but it's actually very intuitive. So the notion is that these 2 nibbles have a value in it, but it's a weighted value. So for example, if the value in here is 8, and that's associated with the number 800. So if that's 7, that's associated with the number 70. And so the way I'm going to do this, the coolest algorithm for this is to put it into a while loop and keep adding 100 for as long as I need to, and then every time through the loop, what I'm going to do is decrement this value. And so that's really it on the algorithm. So I'm gonna go ahead and make that algorithm here. You can see it. I'm gonna say, I don't know, for lack of a better word, start. What I need to do is we'll say adjust because I need to shift those bits around. Typically I'm going to shift them in from essentially from up here to down the lowest location on this thing. And what else do I need to do here? I need to say is value 0. If it is 0, then I'm done, and so I can move on. If it's not 0, what I'm going to do is, we'll call this the hundreds. I'm going to add 100 to something like an accumulator, and then I'm going to decrement. I'm going to decrement the value and then do it again. But it is a while loop. I am going to check the condition first on this, and essentially that's it. So once again, when I write this code, the most complicated part of the code is actually this algorithm right here, but I do it twice. So what that's going to allow me to do is essentially cheat on it and look at my own code and kind of copy that code for a different value. And lastly on this thing, when you get to the ones, I don't need a special algorithm. The ones, unlike the tens and the hundreds, they're not weighted, so I can simply add them to the result, and at that point I'm going to be done with this thing. So we can start writing this. Looks like I got a little extra time here, so I'm going to go ahead and just get this problem started, and we'll fill it out and when I restart this video, because it's already kind of running long. So I'm going to start way up at top here. I'm just going to call this convert, just a label. I start all my subroutines with an init label. There's always something that needs initialization, and so I am going to put that label there. And so there are actually many ways to do this problem. I'm going to choose one way. The solution follows this, or a solution follows it. I don't know if I will match that solution or not, but go ahead and crank through this thing, and I'm going to go ahead and I think I'll call that done now, and then we'll restart this problem in the next video.